Chapter 6 covers the use of control structures. Control structures include conditional statements and loops. Conditional statements allow you to make decisions about how your program should proceed. You test a condition, then perform some action based on the results. Loops allow you to repeat an action over and over. You specify the number of times to repeat. PHP includes two conditional statements, the if and the switch. We'll cover these in detail in the next several slides. There's also additional information and examples in the links at the bottom of the slide. The if condition. The syntax for the if statement is, if some condition is true, then execute some statements. Look at the example on the slide. We create a variable year with a value of 2020. Then we test to see if the value in year is equal to 2020. If this is true, then we print a message, year is 2020. Try this code in PHP Fiddle to confirm the results. You should see the expected results on the Window tab. There are several common mistakes when using the if condition that you should try to avoid. All statements in PHP must end with a semicolon. That includes all the statements within the if condition. Every opening curly brace must have a closing curly brace. Notice in the syntax and in the example on the previous slide that both contain curly braces. Forgetting either will cause an error. And don't use a semicolon after either curly brace. Curly braces identify a block of code and do not require semicolons. PHP uses the Boolean values of true and false when testing conditions. So when we say that the if statement tests to see if some condition is true, we mean, does the condition equal the Boolean value of true? Otherwise, it is false and not executed. Look at the example on the slide. We create a variable OK and set the value to true. Then we test to see if the condition is true. In this case, the condition is simply the value of OK, which we previously set to true. So the condition is true. Then we print a message, everything is OK. Try this code in PHP Fiddle to confirm the results. You should see the expected results on the Window tab. Validation functions. PHP includes several functions that are used to validate form data. These are functions used to test the information entered on the web form by a user. Three that are used most often are empty, isSet, and isNumeric. The empty function checks to see if a variable has an empty value. In this case, an empty value means has no value, has a value of 0, or has a value of false. Look at the example on the slide. We create four variables. One without a value, one with a value of 0, one with a string value of something, and one with an empty string. Then we run the empty function on each of the variables. According to the definition, the empty function should return true for all of these variables except var2. The var2 variable is the only one that is considered as not empty. Try the code in PHP Fiddle. you should see the expected results on the Window tab. You won't see true and false as you might expect. When you print a Boolean value, the true prints as a 1 and the false prints as nothing. So you see ones where the empty function returns true and nothing where the empty function returns false. The isSet function checks to see if a variable has any value. It returns true if the variable has any value, including 0, false, or an empty string. It returns false if the variable has no value. Look at the example on the slide. We create 4 variables. One without a value, one with a value of 0, one with a string variable of something, and one with an empty string. Then we run the isSet function on each of the variables. According to the definition, the isSet function should return true for all of these except the variable var. The var variable is the only one that does not have a value. Try the code in PHP Fiddle. You should see the expected results on the Window tab. Remember that true prints as 1 and false prints as nothing. The isNumeric function checks to see if a variable contains a numerical value. It returns true if it does, and it returns false if it doesn't. As you would expect, any integer or decimal value is considered numerical, so it returns true. But you might not expect that a string that contains a number is also considered a numerical value and returns true. Look at the example on the slide. We create 3 variables. The first one is obviously a number. The second is a string that contains a number. And the third is a string that does not contain a number. When you run the isNumeric function on these, the first 2 return true and the third one returns false. Try the code in PHP Fiddle. You should see the expected results on the Window tab. Again, remember that true prints as 1 and false prints as nothing. Using else. The syntax for the if-else statement is, if some condition is true, then execute some statements. Otherwise, the condition is false, and execute the other statements. Look at the example on the slide. We create a variable year with a value of 2021. Then we test to see if the value in year is equal to 2020. If this is true, then we print a message year is 2020. Otherwise, this is false, and we print a message year is not 2020. Since year is set to 2021, we expect to see the message printed from the else portion of the if-else statement. A quick side note here. You may have noticed that sometimes you see certain portions of the code indented. For example, the code in the if block is indented and the code in the else block is indented. This is a very common coding practice. Statements inside a code block are usually indented. This makes the code much easier to read, especially for blocks that contain many lines of code. Even just quickly viewing the code, you can see that certain sections of code belong to the same code block. It's highly recommended that you follow this coding practice. Try the code in PHP Fiddle to confirm the results. You should see the expected results on the Window tab. For clarification, the else is considered the default action. It's executed when the condition is not met, in other words, is not true. The condition has to be true for the if portion to execute. More operators. Previously, we discussed the arithmetic operators. For example, addition, subtraction, multiplication, and division. And we discussed the plus plus and minus minus as shortcuts for incrementing and decrementing by 1. And we discussed the equal sign for assigning a value to a variable. Note that the textbook has a typo in some of the operators. The slide has been corrected. When creating conditions, we need to discuss the comparison and logical operators. You can see example of these on the slide. Note again that the textbook has a typo in some of the operators and the slide has been corrected. You can also see a list of the PHP operators using the link at the bottom of the slide. Comparison operators. When doing comparisons, you're testing to see if values are equal or if they are different in some way. To test that two values are equal, use the equality operator, the double equal. This is different than the equal sign, which is used to assign a value. This is a very important difference that we'll discuss in a moment. To test that two values are not equal, use the inequality operator, the exclamation equal. The exclamation actually represents not, in this case not equal. The less than and greater than operators are pretty much as you would expect. They test to see if the values are different in a specific way, like, is one value less than another? Look at the code example on the slide. We use the equal sign to assign a value of 5 to the variable var. Then we use the equality operator, the double equal, to test whether the values are equal. This is a very common mistake. The results are very different. You must use the double equal in a condition to test that two values are equal. If you use the single equal sign here, you will most likely get unexpected results. Be very careful to use the double equal instead of the single equal in conditions. Logical operators. At a basic level, conditions identify when a particular situation is true or false. A condition is true if it makes sense, like 5 is greater than or equal to 3. This is true because 5 is greater than 3. A condition is false if it doesn't make sense, like 5 is less than or equal to 3. This is false because 5 is not less than and not equal to 3. In fact, it's just the opposite. It's greater than 3. We can use logical operators to create more complex conditions. Use logical operators to create conditions with multiple parts. When using AND, every part of the condition must be true for the whole condition to be true. The AND operator can be represented by either the word AND or double ampersands. When using OR, at least one part of the condition must be true for the whole condition to be true. The OR operator can be represented by either the word or double bars. When using exclusive OR, at least one part of the condition must be true, but not both parts. The exclusive OR operator can be represented by the characters XOR. Look at the examples on the slide. The first two conditions result in true. If 5 is less than or equal to 3, which is false, or 5 is greater than or equal to 3, which is true. Since one of the conditions is true, then the entire condition is true. If 5 is greater than 3, which is true, and 5 is less than 10, which is true. Since all of the conditions are true, then the entire condition is true. The second two conditions result in false. If 5 is not equal to 5, which is false, and 5 is greater than 3, which is true. Since all conditions are not true, then the entire condition is false. When using and, all conditions must be true for the entire condition to be true. If 5 is not equal to 5, which is false, or 5 is less than 3, which is false. Since neither condition is true, then the entire condition is false. When using or, at least one of the conditions must be true for the entire condition to be true. Also notice the use of parentheses. Remember that all operations take place in the order of their precedence. Instead of taking a chance, use parentheses to cause things to happen in the order that you choose. Here are a few things to remember when using conditional statements. The entire condition must be true to execute the statements associated with that condition. Use parentheses and conditions to ensure that your operators execute in the order that you choose. Every open parenthesis or curly brace must have a closing parenthesis or curly brace, and they must be nested properly to avoid unexpected results or errors. Nesting conditionals. Just like you put statements inside of the if and the else parts of an if-else statement, you can put if-else statements inside as well. This is called nesting conditions. It happens when you want to make decisions based on the results of other decisions. So, for example, you see condition 1. If condition 1 is true, then we check condition 2. If condition 2 is true, then we run statements 2. Otherwise, condition 2 is false, and we run other statements 2. If condition 1 is not true, then we run other statements 1. As you might have guessed, nested conditions can get complicated and hard to follow. Using indentation and curly braces properly and adding comments will help to make it quite a bit more understandable. You will see examples of nested conditions throughout the rest of the textbook. Using else-if. The syntax for the if-else-if statement is similar to the if-else statement, except it includes additional conditions that act like a running if statement. If condition 1 is true, execute statements associated with condition 1. Otherwise, if condition 2 is true, then execute the statements associated with condition 2. Otherwise, if all previous conditions are false, then do nothing as in the first syntax example, or execute the default statements in the else code block as in the second syntax example. Look at the example on the slide. We create a variable year with a value of 2021. Then we test to see if the value in year is equal to 2020. If this is true, then we print a message year is 2020. Otherwise, we test to see if the value in year is equal to 2021. If this is true, we print a message year is 2021. Otherwise, if both are false, then we print a message year is not 2020 or 2021. Since year is set to 2021, we expect to see the message printed from the second condition. Try the code in PHP Fiddle to confirm the results. you should see the expected results on the Window tab. The switch conditional. Switch is another type of conditional statement. Like the if-else-if statement, it checks conditions and runs code when a condition is true. It is sometimes used to replace very long if-else-if statements. The syntax for the switch statement is: start with the switch keyword and include the variable to test inside the parenthesis. The switch statement will try to match a value with this variable. Then you have multiple case statements. Start each case statement with the case keyword. Then each case statement contains a value. This is the value that will be compared to the variable from the switch statement above. Inside each case will be one or more statements. These are the statements that will run if the variable matches the value for that particular case. At the end of each case will usually be a break statement. This tells the switch statement that a match was found and that it's time to exit. Finally, you will typically have a default statement. This is what happens if no match was found. Note that the syntax for the switch statement is very particular. All parentheses, curly braces, colons, semicolons, and switch, case, and break keywords must be as you see them in the example. If you forget or misplace any of these, the switch statement will create unexpected results. To see how it works, let's try the example from the link at the bottom of the slide. A variable favColor is created with a value of red. Then start the switch statement. The switch will test the value of the favColor variable. Then include the case statements. Each case statement contains a specific value to compare with the favColor variable. So, if the value in favColor is red, then execute the statements in the first case. If the value of favColor is blue, execute the statements in the second case, and so on. Finally, include the default statement. This will execute when the value of favColor is not specified in any case. For example, if favColor is set to purple. Run the code. You should see the favorite color is red message. Change the value in favColor to blue or green. You should see the message associated with that color. Then change the value in favColor to something else. You should see the message from the default statement. The for loop. Loops are used to run a section of code repeatedly until some condition is met. For example, you could use a loop to print something for a certain number of times, or to process each item in an array. In PHP, there are three types of loops: the for loop, the while loop, and the for each loop. We will cover the for loop in this chapter. The for loop is used to run one or more statements for a specific number of times. The syntax for the for loop is shown on the slide. Start with the for keyword. Then, in parentheses, you have three parameters. The first is the initial expression. This will initialize the loop counter value. Then a semicolon. The second parameter is the condition. This is where the loop checks to see if it should continue or not. If this is true, the loop continues. If not, the loop exits. Be very careful here. The condition has to eventually become false for the loop to exit. As long as the condition is true, the loop will continue. If it never becomes false, you have an infinite loop. Then a semicolon. The third parameter is the closing expression or the increment counter. This is where the loop counter value is incremented. It executes after the statements inside the for loop. Like most other PHP statements, the syntax for the for loop is very particular. All parentheses, curly braces, and semicolons must be as you see them in the example. If you forget or misplace any of these, the for loop will not work correctly. Look at the code example on the slide. The for loop works like this. First, initialize a loop counter variable I and set the value to 1. Next, check the condition to see if I is less than or equal to 10. If so, execute the print statement inside the for loop. Then, increment the loop counter I by 1 using the I++. Keep doing this until the condition is no longer true. In this case, when I is no longer less than or equal to 10, so basically when I is incremented to 11. Try this code in PHP Fiddle to confirm the results. You should see the expected results on the Window tab. Now change the condition to check for some number other than 10. You should get that many lines printed. Again, be very careful about your condition. It eventually has to become false for the loop to exit. It will keep running as long as the condition is true. For example, think about what would happen if you change the condition to I is greater than or equal to 1. Don't do this, just think about it. I is initialized to 1. Then we check to see if I, which is 1, is greater than or equal to 1. Well, it is, so we execute the print and increment I. Now I is 2. And we check to see if I, which is 2, is greater than or equal to 1. It is, so we execute the print and increment I. Now I is 3. And we check to see if I, which is 3, is greater than or equal to 1. It is, so we execute the print and increment. Do you see the problem? I is always greater than or equal to 1, so the condition is always true. It never becomes false, so the loop never exits. You have an infinite loop.